Did you break your Nintendo Switch port like this? We have one bit pin that's making contact with ground, and I'm going to walk you through how to fix it. The first thing we have to do is disassemble this switch, remove the port, and then we can test from there. This video is brought to you by PCB Way. We'll talk about their promotions in a minute. Spared you from the boredom of disassembly, and I am prepared to remove the port. While I am setting up my equipment, I'll throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon Associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. We're going to flood these anchors with a low melt. We're prepared to blow this port right off the board. Actually, it's just going to drop off the board. First thing we want to do is wet the anchors. And once we have seen that they are wetted, we will concentrate in on the pins and the port will drop. Like so. Nice clean pull. What you don't want to see here is any copper pads on those pins on the port, and there are none, so excellent. First thing we're going to check is make sure that we do not have any bridged pads, and we do not. And what do I mean by bridge? If solder has crossed over to one of those other pins or pads, that would interfere with our readings while we're doing tests. We do not want that to happen, so everything looks good. We're going to begin our testing around the M92T36, which is a PMIC. But the first capacitor we're going to test is actually connected to the Pi 3 USB on the back of the board, which is the USB-C controller. And the line we do not want to have a pathway to ground is this line going to the chip. We'll test that. Excellent. And now we're going to check those lines on the capacitors going around the chip for any shorts on the M92T36 itself. So far, so good. Now, the exception to the rule is this capacitor right here. It has two lines going to the chip. In that case, one side will always be ground. As long as one side is ground, you are good. This capacitor right here, I don't know that it's actually tied directly to the CPU, but if it is shorted on the line going to the chip, it's usually a really bad sign. And it seems we're good. Excellent. And we're going to check around our MOSFETs. I have had one issue in this area, so I always check it. Very good. And we're going to check our little filter, make sure he has continuity through him, but no short side to side. We're going to check our invincible fuse. Why do I call it the invincible fuse? Because I have seen the entire system get blown up and that fuse still be good. Now we're going to check our test pads. None of these test pads in this area should have any pathway to ground. If it does, we have a problem, usually M92 related. And we do not. Excellent. And we'll check these two pads as well. Neither one should have a pathway to ground, and they do not. This coil should not have a pathway to ground. It does not. But it should have continuity through the coil. And it does. Now we'll check the BQ241A3. Same rules apply, but this one has multiple capacitors with two lines going to the chip. I just generally know which sides to check. Alright, and that one should not have a pathway to ground, and it does not. We have flipped the board over and we are now looking at the Pi 3 USB. Just like on the M92T36 and the BQ241A3, we want to check capacitor. In this case, it's the one single capacitor we're going to check. And the line we do not want shorted to ground is the line going to the chip, which is this side. And it appears to be fine. We're going to check our filters. Make sure they have continuity going through. Now you may have to work through some manufacturer residue like a leftover flux or stuff like that. They control you, so be thorough. Make sure you're actually making connection. Okay. And check them side to side. Make sure they are not shorted side to side. Next step is going to be to prep this area for a new port. In order to do that, we must get all this solder off the board. Wicking is a skill you have to learn. The main thing to understand is it is not a scrubber. It does not require any more pressure than it takes to keep it on the board, and you just want to glide with it. You do not want to scrub. When it comes to wicking these pads, I advise you start at the top and go with the pads. Do not try to go across the pads. Now we're going to place a ball of solder on our tip, and we're going to flow over the pads with just the ball of solder. May make incidental contact with the iron. And again, we're going to add a nice ball of solder on our tip, and we're just going to glide over with the ball. Excellent. We are wetted. I'm going to press it down. hold it down, and I'm waiting for signs for these outer ones to dry, and then we're going to hold it down for a tick longer just to make sure those hidden ones dry. We're going to take a look at this outer row and make sure everything is solid. When you're concentrating on that inner row, you can sometimes neglect these outer ones, but everything looks solidly in place. Excellent. We're going to add a ball of solder to get things started, and we'll feed in a fairly generous amount here. These top ones in this orientation take a little bit more. Doesn't take quite as much for these. Pretty reasonable. I'm going to clean this board thoroughly. I'm going to clean out the port thoroughly, and then we'll set up for some testing. PCB Way is offering $5 for up to 10 pieces of 1 to 2 layer PCBs with a 24-hour turnaround. Single pieces, 2 layers, FR4 material, a few solder mask options, silkscreen options, and much more. Click the link in the description, head over to PCBWay.com, and check it out today. We're prepared to do some testing now. First test I'm going to do is with my USB-C dongle hooked up to my benchtop PSU. What I want to see here is on PSU channel 1, the amp meter, I want to see the current go up and then basically go right back down on both sides. And I'm getting 0 here. Strange. Yeah, I'm getting flat 0. We may have a problem we have not detected or attempt to power up. What we want to see here is a steady climb in amperage, no hanging. Okay, it seems like it's booting up. Interesting. I wonder why we were not getting power on the PSU side. I'm going to flip it around and see if I can activate from the other side. It is not recognizing the other side. So we definitely have an issue. Out of curiosity, I'd like to see if we're getting dock. So negative on dock. We're going to try with the battery on the PSU. Nothing on that side. Okay, we're definitely getting one side charging. So could be my port work, but I'm strongly suspecting it is the M92. I hope this video is being helpful to you in your repair journey. Just a reminder, if this is something beyond what you want to try yourself, I do offer these services. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. So unfortunately, this looks like it's going to be another one of those weird cases where I'm just going to have to guess based on prior knowledge. I really hate cases like this for video because it really doesn't teach you anything. Good, good, looks good, and looks good. Connect our battery again, see if we get some behavior that we would like to see that looks kind of normal. We want to reset, okay, and now we'd like to see it go fast charging. Very good, make sure that's happening on both sides, and it is. Excellent, that's great news. Let's check docking, and we are docking. So it was the M92 T36 that was causing our problem. That is excellent news. We will reassemble, let it charge on its own battery, and run it through our battery of tests. We're back up on its own battery. And we want to perform a few tests. Make sure it's picking up its Joy-Con and charging them. And we are. Excellent. We're picking up the networks. If you like this video, do me a favor and check this one out here. I think you'll like it too. And I'll see you there.